Now, for this particular part of the term that we're in, quadratics is going to make up a huge part of it. We're going to graph them, we're going to translate them, we're going to shift them around, and we're going to solve them as well. And one of the key things we're going to be using is a thing called the Null Factor Law. It basically means timesing two numbers together to get a result of 0. So here's some examples of what you'll be doing. Now, in this situation here, we've got this quadratic on the left. And I know it's a quadratic because if I expanded it, x times x is going to give me x squared. So that's a quadratic. So somehow there's at least one, maybe two values of x that I can substitute into here that will make this equation true. Get a result of 0. And we've got to find them. And we're going to use a thing called the Null Factor Law. Now what you really need to notice here is we've got two numbers multiplied together. First number is this unknown value, which we've called x, and the other number is the contents of the bracket. Remember, whenever you see the set of brackets, you always treat it as if it was just one number. It doesn't matter how messy or ugly or complicated inside the bracket is. Think of the bracket, it's just, all it is one number. So I currently have two numbers multiplied together to get a result of 0. The only way that can ever happen is one of the numbers has to be equal to 0. So it's either the first number is equal to 0 or the second number is equal to 0. So there's my only two possible results. The first number could be 0 or the second number could be 0. Of course, I'm not actually interested in what x minus 2 is equal to, I'm interested in what the unknown value is. So for that to be true, if I take that minus 2 from the left and place it onto the right, I have that situation. So x being positive 2 or x being 0 are my two possible solutions to that quadratic. So if I put 0 into here, I've got 0 multiplied by negative 2, that's 0. I put positive 2 in here, I've got 2 multiplied by 0, that's 0. So yes, there's my two possible solutions using the Null Factor Law. I'm going to give you 10 different ones to look at in this particular video. You don't need to memorize 10 different ways, it's just that you're going to see it set up in all these different manners. So let me write a couple up and we'll start working on them. Okay, we'll start with these ones for now. So we've done the Null Factor Law, so here we have two numbers times together to give a result of 0. So look at example number 2. I also have two numbers multiplied together to give 0. The first number is that bracket and the second number is that bracket. So because it's two numbers times together to be 0, either the first one is 0 or the second one is equal to 0. So I have two very simple linear equations to solve now. So either x is going to be equal to positive 1 or x has to be equal to negative 6. And they are my two solutions to that equation there. This one, I have two numbers multiplied together to give 0. 4 multiplied by x squared, so one or the other has to be 0. Well, clearly 4 can't be 0, so the only situation is that x squared has to be equal to 0, which means x itself has to be equal to 0. Only one solution. Two solutions there, two solutions there, only one solution there. Number 4. I've got two numbers multiplied together. I've got x plus 1 being multiplied by x plus 1. So, square. So if I undo the squaring on both sides, take the square root of both sides, square root of 0 is 0. The only possible solution is the unknown value up here must be minus 1. It's the only value that I can put in here to make the result equal 0. So far, very simple and straightforward. They've all just been two numbers multiplied together. Now, question number 5. I haven't got two numbers multiplied together. I've got two numbers added together. 3x squared and negative 6x. Now, just a little bit of a word of warning here. A lot of people they want to solve for x. Oh, I see the x squared here. For some reason, a lot of people try and pick up this minus 6x and try and place it on the right-hand side. So So 3x squared was equal to 6x. It's a true statement, but it's not going to help us anywhere in any way whatsoever. It ain't going to get us anywhere. When you've got an x squared term and an x term, keep them on the same side of the equal sign. That's important. You must keep them on the same side. When you've got this situation, this is the simplest possible, the most straightforward one you're going to come across, because all you need to do is just factorize these two terms. Look at this and look at this. What do they have in common? Well, they have a 3 in common and they have an x in common, so you factorize them out, leaving you behind one lot of x. Take away 3 goes in 6 twice, x is accounted for, voila. I've taken it from two numbers added together to two numbers multiplied together, which means either the 3x is equal to 0, which means x itself is equal to 0, or x minus 2 is equal to 0, x must be equal to positive 2. There's my two possible solutions. Now, example number 6. Just like I said up here in number 5, when you have these two x terms, don't put one on one side and one on the other. That's going to lead you nowhere. That's what I have here. I've got one on one side, one on the other. It's not going to lead me anywhere. Now, you might be tempted to divide both sides by x. If you did that, you will get one of the possible answers, but you'll lose the other one. There's two answers to this, and if you divide both sides by x, you'll lose one of the answers. Not to mention there's a mathematical problem going on there as well we can talk about in class. So regather them onto the same side. So the positive x comes over to become negative x. I now factorise them. Number-wise, nothing in common. Letter-wise, x is the only thing in common, leaving 11x, take away 1 inside the bracket. Two numbers times together. So either the first one is equal to 0, or the second one is equal to 0, which means 11 lots of the unknown must be positive 1. The unknown itself must be 1 on 11. And there are our two possible answers. You're not always going to get nice, neat, easy, whole numbered answers like you have over here. Sometimes you're going to get some messy, ugly fractions, some messy, ugly surds, square root symbols. It isn't always going to be neat and tidy. If you follow the same procedure, you'll get the right answer every time. So let me clean this off and we'll go for our last 4 examples. Now, example number 7, 4x squared equals 25. Now, I said before, if you've got two terms with x in them, avoid putting one on one side and one on the other. That's just going to lead you nowhere. But we don't have that situation here. We've only got one term that has an x in it, 4x squared. And then we have this constant term of 25. This is the time when you can have one term on one side, one term on the other, because we want to isolate the unknown pronumeral here. So everything else goes on the other side. Since 25 is a known value, let's put it over there, so we're going to start dealing with it. So I'm going to put the 4 over with it as well. Divide both sides by 4. You can do that if you want to and get, what, 6.25, but I wouldn't bother if I were you. Leaving it as a fraction is really just the best thing to do at the moment. Now if I undo squaring by taking the square root of both sides, square root of 25 on 4, the square root gets applied to both the top number and the bottom number. So square root of 25 is 5, square root of 4 is 2. Because we're taking the square root, we need to consider the positive and the negative answer. So it's going to be positive 5 on 2, 2.5, or negative 5 on 2, negative 2.5. There's your two possible solutions. Now we've arrived at the beginnings of possibly the more complicated ones. We've now gone from having two terms multiplied together to two terms with x's involved added together, two terms with only one lot of x involved added together, or on opposite sides of the equal sign. Now we've got 3 terms added together, a full-blown heavy-duty quadratic. We need to find what two values, if indeed there are two values, of x that will satisfy this particular equation. First thing you should look for, it's I call it unitary quadratic. It's one lot of x squared. They're easily, can it be factorised? If you can factorise it, factorise it. So numbers that times together to give that will be negative 4 and negative 2, and which add together give negative 6. So negative 4, negative 2. There we are. That quadratic's now factorised. Instead of 3 terms added together, I now have 2 numbers multiplied together. So therefore, since they multiply to give 0, either the first term is equal to 0, so x is positive 4, or the second term is equal to 0. X must be equal to positive 2. If you can factorise, factorise. Makes life simple and easy. Now, speaking of factorising, this one is a heck of a lot easier than it might look. It's a non-unitary quadratic, non-monic quadratic. It's 2 lots of x squared. And I've got 2 numbers added together on the left equaling a number on the right. With quadratics, just get everything over onto one side, leave 0 on the other, makes your life a lot easier. So I'm going to move the 24 over. So I've got 2 lots of x squared plus 8x, take away 24 is equal to 0. Now, believe it or not, that factorises very, very easily. Because I've got 2 lots of x squared, it looks difficult. So what I'm going to do is, I notice that the 2 can go into 2, it goes into 8, it goes into 24. So I'm going to factorise that 2 out the front, leaving 1 lot of x squared there, 4 lots of x there, negative 12 there. So I've got 2 numbers multiplied together. Well, if I divide both sides by 2, which I'm allowed to do, I come down to that. That's very easy to do compared to the original. So that's going to factorise to x plus 6, x minus 2, voila. 2 numbers times together, so there's my 2 possible solutions, negative 6 and positive 2. And finally, after this long video, here's my last one for you. Negative x squared. So when we had 2 lots of x squared, it was a pest. Negative x squared. Look, there's a couple of different things you can do here. They produce exactly the same result. You could, this negative x squared, it's a pest. You could pick up every single one of these 3 terms and move them over onto the right hand side. So if I get this negative x squared and move it on to the right hand side, it becomes positive x squared. Minus 4x from the left, bring it over to become positive 4x on the right. Take the positive 12 from the left, bring it over to become negative 12 on the right, and I'm left with 0 on the other side. That is something you could definitely do. That's factorises really easy. Matter of fact, I've already done it for you. So you could move everything from the left to the right so your x squared term becomes positive. You could, if you wanted to, take the entire left hand side and multiply it by negative 1. Therefore you have to take the entire right hand side and multiply by negative 1, and you'd end up with that. Or you could take the entire left hand side and factorise out negative 1, and you'd end up with that. So if you've got things in front of x squared, can you do something to make your negative x squared to a positive x squared? If you've got 2 lots of x squared, can you do something to make it 1 lot of x squared? If you can, do that, makes your life easy. If you can't, well, we're going to find out about them in a lesson or two's time. So see you in class, and we'll have good luck with these ones, okay?